So today I will talk about the coordinate system and the position vector. So in actual practice, vectors are represented in coordinate system. So as the coordinate system play a very important role. So first of all, talk about the coordinate system, that what is a coordinate system. So let me talk about its definition now. Coordinate system so in geometry coordinate system is a system that uses one or more numbers or coordinates to uniquely determine the position of the points or points or any object with respect to some reference point and we call this reference point as origin. We call it origin. In the Euclidean space. So this is the definition which I have taken from the Wikipedia, and let me describe it now diagrammatically. So consider a two-dimensional space and say this is the origin and I want to be arrived at this point. So what I will do, I move along the horizontal along this direction and I move along the vertical along this direction. Then I will be reaching at this point. Say 1, 2, 3 and 4. It's 4, and here 1, 2, 3 and 4. Then I will reaching at this point. So that means this P point can be represented as 4, 4. Or say I move 2 steps here and I want to be here, so that means I move along this, say 1, 2, 3 and 4. So that means the point is, this point is known as 2, 4. So this is the position of this point. But actually space is three-dimensional. So let us take the example of three-dimensional space. So that means a particle will be here, say it is the origin, and what I will do, say this is x-axis, this is y-axis, and say it is z-axis. So say 3 steps I move along x-axis and then I move along y-axis. Say 1, 2, 3, 4 and 5 steps, right? I will be here. Now along vertical direction I will move 5 step, 1 2 3 4 and 5. Then this is the point at which I will be here. So that means it is 3 1 2 3 4 and 5, 1 2 3 4 and 5, 5 5. So this is the position of this point. So this is a way, so that means this is the position in the Cartesian coordinate system with respect to the origin, right? So this is the position. So that means we are talking about a point or a number of points in the with respect to some position, sorry, with respect to origin. So now let us talk about the position vector. This is the Cartesian coordinate system. Now let me talk about the position vector and how it can be represented. Again I will consider such type of diagram. So let me talk about the position vector. So that means this is my coordinate system. Say it is x-axis, it is y-axis, and say it is z-axis. And let us assume that unit vector along x-axis is represented by I cap, and the direction along y is represented by j cap, and along z it is represented by k cap. So a particle will be here. So what I will do, let us say that I will move a distance x along x-axis. Say this distance is the x vector. Let me call this as x vector also. So this x vector is basically, it can be written as xi cap, is if x is the magnitude, and say I moved along y-axis. Say this vector is known as y vector, and then along z-axis it is the z vector. Now if origin is connected to this point P, then this is known as the position vector, R vector. Means y is basically yj cap and z is equal to zk cap. Now if we try to look at it, this particular diagram, it's a very beautiful diagram. So what I did to arrive at this, I moved x distance along x-axis, then I moved a y distance along y-axis, right? And say, consider this one, say it is the row. So if I apply a triangle of vector addition over this OAB, so in this OA vector plus AB vector is OB vector. So it is row vector, it is x vector, it is y vector. And similarly, but I am at point P. So to arrive at point P, if I again consider this OBP triangle, then in this OBP triangle, OB vector plus BP vector is equal to OP vector. So what is it? It is row vector plus it is z vector and it is R vector. It is the position vector basically, because R represents the position of particle P. So that means this R vector is equal to row vector plus z vector, but the value of the row vector is x vector plus y vector plus z vector. So it can be written as xi cap, yj cap and zk cap. So thus position vector is represented like this: xi cap, yj cap and zk cap. This is a way to look at it, right? So if it's only a single point about which I am talking about, if there are 2 points in the space and how their position vectors can be represented, let us have a look at that. It is x, it is y, it is z. So consider 2 points. Say one point is A will be here and B point will be here. Then it's a, and after time this will be, and its coordinates will be x1, y1, z1, and its coordinates will be x2, y2, and z2. Then this, let me call it as r1 vector and let me call it as r2 vector. So then OA vector, we call it as r1 vector. It can be written as x1 I cap, y1 j cap, and z1 k cap. Similarly, OB vector can be written as r2 vector. It is equal to x2 I cap, y2 j cap, and z2 k cap. Then the displacement vector means initially particle will be at point A and after time it will reaches at point B. Then the displacement vector AB, it can be written like this. If I apply a triangle of vector addition over it, then say this displacement vector is represented by r12. So this, if I apply triangle of vector addition, then r1 plus r12 is equal to r2. Then r12 can be written as r2 minus r1, means it is r2 minus r1. So this is final minus initial. This is final minus initial. This is a way to look at it. So that means r12 vector can be represented as r2 minus r1 vector. Right? So this is all about this coordinate system and the position vector